Now, so far, every GCF we've had in every example has been a monomial, but sometimes the common factor can be an entire set of parentheses, so the common factor can actually be a polynomial all on its own. Let's start out looking at this simple expression and then I'll show you what I'm talking about. So let's look at x times k plus 7 times k. And I think you would agree with me that the GCF here is k. And so we're going to need a set of parentheses big enough to hold two terms. And then we'd have to say k times x will make this first term, and k times 7 will make this second term. And I don't think probably anybody who watched part 1 has a problem with this. But now look at this expression. Here we have x times y plus 3 plus 7 times y plus 3. And even though it looks a little different, notice that this group is sort of a term all by itself, and this group is also a term all by itself. So if you think of this as x times something plus 7 times the same something, you can treat it like we treated this first one. So what these two terms have in common is their y plus 3. So we will factor out the y plus 3, and now we'll need a set of parentheses to hold two terms. So what can we multiply times y plus 3 to make this first term? Well, we would need to have y plus 3 times x. And then we'd have a plus sign. And what would we have to multiply by y plus 3 to get the second term? Well, the second term is y plus 3 times 7. So the second term would need to be plus 7. Now think about it. Y plus 3 times x makes this first group, and y plus 3 times 7 makes this second group. So I know the first time you see it, it looks very strange, and I think probably the first time you see this, your inclination is you want to distribute the x and distribute the 7. But notice that the reason we did not do that is because we're trying to factor, not distribute. So here's example 5, and we're going to just continue practicing factoring out the common binomial. So here I have a times a plus 3 plus 4 times a plus 3. Both terms contain a factor of a plus 3. So a plus 3 is the common binomial. So I'll factor out that common factor, and now in parentheses I'm going to need an a and a plus 4. Okay, now notice that a plus 3 times a gives this first group, and a plus 3 times 4 gives that second group. And let's try it again on part B. Here we have x squared times x plus 1 minus 5 times x plus 1. So notice that both terms contain a factor of x plus 1. So we will factor out the common factor, which is x plus 1, and then in parentheses we'll have x squared minus 5. So you can see that x plus 1 times x squared would make this first group, and x plus 1 times minus 5 would make this second group. Now notice that both parentheses must be exactly the same, or else they are not common and cannot be factored out. So for example, looking back at part A, if I had a plus 3 here, but then I had a plus 5 in this second parentheses, I would not be able to do what we did there because we would not have a common binomial. Also notice that in your final answer, the order in which you write the two factors does not matter because of the commutative property. So if somebody were to write this answer as a plus 4 times a plus 3, you know that has the same value as a plus 3 times a plus 4. Now I want to caution you about a mistake that a lot of people make, and I mentioned it a little while back. Notice that distributing and factoring are opposites. They are opposite processes. Just because you can distribute does not mean that you should distribute. So here notice that I have the same expression written twice, but these are very different problems. So this first one has instructions that say simplify. And remember, simplify means to distribute and combine like terms. So if I'm going to simplify here, first I'm going to distribute this x squared, so that would give us x to the third plus x squared, and then I'm going to distribute this negative 5, so negative 5x minus 5, and then I would see if I could combine any like terms, and here we can't, but this is considered simplified. Notice that here our answer is in terms, not factors. X to the third is a term, x to the second is a term. On the other hand, if our instructions say factor, then we need to write this in a multiplication form. So we're going to look for the common factor, and we see that they both have a factor of x plus 1. So I would pull out the x plus 1, and then my second set of parentheses would be x squared minus 5. Notice that this expression is written in factors, not terms. X plus 1 is a factor, and x squared minus 5 is a factor because they are multiplied together. Here, these are terms because they are not being multiplied together, they're being added and subtracted. So the difference between these two sets of instructions is the same as the difference between turning right and turning left. You can do either one most of the time, but you have to know where you want to end up. If you want to end up with a simplified answer, you distribute. If you want to end up with a factored answer, you factor. They're opposites. Now that we know how to factor out a common binomial, we're ready to talk about the grouping method. So if a polynomial has 4 terms and no GCF, that's a good time to try the grouping method. To factor by grouping, these are your steps. First, factor the GCF from the first 2 terms, then factor the GCF from the last 2 terms, and then if the binomials are the same, factor out the common binomial. This step 3 is what we were just doing on the last couple of slides. Now here are a few tips about factoring by grouping. If there is no GCF other than 1, use 1 as the GCF. If the second group begins with a minus sign, then you must factor out a negative from the second group. And I'll show you why in just a few minutes. And always use the FOIL method to check your answer, at least mentally. Of course, you don't have to write it down, but you should run through it in your head and make sure that your answer makes sense. So here we are at example 6, and we're going to practice factoring by grouping. Notice that our expression contains 4 terms, and notice also that there's not a GCF. There's nothing common to all 4 terms. However, this is a perfect time to try the grouping method. So we think of the first 2 terms as a group, and we factor the GCF from the first 2 terms. Now notice both of these contain a factor of 2, so I can write this as 2 times x plus 3. And then look at the second pair of terms, and this is the second group. And notice that these 2 terms contain a common factor of a. So I'll have a plus sign, that's this plus sign here, and I'll have a common factor of a, and then in the parentheses I'll need x plus 3. Okay, so you see how we factored the GCF from each group. Now notice that we have a common binomial, so we can factor out this x plus 3. And if we factor out the common x plus 3, then we'll have x plus 3 times 2 plus a. Now mentally, let's just check and make sure that this answer makes sense. First times first would be 2x, that's this first term. Outer times outer would be ax, that's the third term. Inner times inner would be 6, that's the second term. And last times last would be 3a, and that's the fourth term. So all the terms are here, it's just now we have our answer in factored form. Let's look at part B together. So on part B, we first notice that there are 4 terms. That's almost always a clear sign that you're going to need the grouping method. And then we notice that there is no GCF that works for all 4 terms. So now the grouping method is really the only thing we can try. So we'll say the first 2 terms make a group and the last 2 terms make a group. So in the first 2 terms we have a 6 and a 24. So the largest number that goes into both of those is 6. And also notice that both of these terms contain an x. So our GCF will need to contain an x. Okay, now 6x times a makes that first term, plus 6x times 4 makes that second term. Okay, now we're going to have a plus sign to get to our second group. And notice that when you look at the last two terms, we would say there's not a GCF, or we really should say that the GCF is 1. And so I'll put down a 1 with my parentheses. And of course, a plus 4 is what's going to go in here, because 1 times a gives us that term, and 1 times 4 gives us that term. Okay, now we notice that both of these groups have a common factor of a plus 4. So if we pull out the common a plus 4, that's going to leave for our second set of parentheses 6x plus 1. And now if you just mentally FOIL it back together, a times 6x is 6ax, a times 1 is 1a, 4 times 6x is 24x, and 4 times 1 is 4. But notice that this is in factored form because we have binomial times binomial. Here are a couple more to work on. So here in part C we have 2x squared minus 10x plus 3xy minus 15y. So clearly we have 4 terms, and there's not a GCF that works for all 4 terms, so we do need to try the grouping method. If I look at the first 2 terms, then I see that my GCF is going to be 2x. And now let's get the binomial that goes with that. So 2x times x gives us 2x squared, and then we need a minus. 2x times 5 would give us 10x. Now we're going to have a plus after that group, and then we need to figure out the GCF for this second group. 3 will go into both coefficients, and both terms contain a y, so our GCF needs to be 3y. And then in our parentheses, 3y times x would make this term, minus 3y times 5 would make this term. Notice that both groups contain an x minus 5, so we'll factor out the x minus 5, and the other set of parentheses will be 2x plus 3y. And here on part D, I want you to notice that the second group starts with a minus sign, and that is very important. So let's go ahead with our grouping method like we've done the last couple of examples, and let's say that the first group is these first 2 terms, and the GCF of these first 2 terms is going to be t squared. Then in parentheses we'll need t plus 2. Now the second group starts with a minus, so I'm going to need a minus here. And we have to ask ourselves, what do these 2 terms have in common? Well, they both have a factor of 3. So we'll have a 3 here. And now be very careful and remember that because we had to put a minus here, we effectively are having to factor out a negative from these last 2 terms. So negative 3 times t would make this first term, but negative 3 times positive 2 is what we need to make this minus 6 here. So remember, factoring out a negative causes us to have to change that sign. That's why you see a plus here. But it's very important that we get a plus here, because if we didn't have a plus here, then these 2 binomials would not be the same and we couldn't finish the problem. Now that we have a plus here, we see that both of these have a factor of t plus 2. So we're going to factor out the t plus 2, and that's going to leave t squared minus 3 for our other set of parentheses. Now, every now and then, you'll run across a problem where you try the grouping method and you don't get a common binomial. And if that happens, then what you need to do is try rearranging the 2 middle terms and start over. So let's try it on this example here. So we have 10x squared minus 12y plus 15x minus 8xy. And you say to yourself, well, I see that there's no GCF and there are 4 terms, so the grouping method is the thing to do. If you look at the first 2 terms, you would think the GCF here is 2, but we would not include an x or a y because that's not common to these 2 terms. So the GCF is just 2, and our parentheses would need to be 5x squared minus 6y. Then we would have a plus. And you look at these last 2 terms, and there's not anything besides 1 that goes into both 15 and 8. but both of these terms do have an x, so x will be our GCF, and in the parentheses we would have 15 minus 8y. Now look at this and notice that we can't do the last step because our binomials are not the same. And what that means is the grouping method has failed here. But before we give up, we should try rearranging these two middle terms and see if that will help. So now let's write it as 10x squared plus 15x minus 12y minus 8xy. So all I've done is rearrange these two middle terms. And now let's try the grouping method again. So this time the GCF for these first two terms is going to be 5x, and in the parentheses we're going to get 2x plus 3. Now the second group starts with a minus, so I'm going to have to put a minus here. And then I look at the 12y and the 8xy, and I say, well, 4 is the biggest number that goes into both 12 and 8, and I see that y is common to these two terms. So I'm going to have minus 4y as my GCF. And then to fill in our parentheses, negative 4y times 3 makes negative 12y, and negative 4y times positive 2x will make negative 8xy. So now notice that we do have the same binomial in each group. The first one is written as 2x plus 3, and the second one is written as 3 plus 2x, but those are the same two terms. So now we can factor out the common binomial, and in the other pair of parentheses we'll get 5x minus 4y. And now let's look at part B. If we just start the grouping method as usual, we'll say the GCF of these first two terms is 2, and in parentheses we would need xy plus 6. The second group starts with a minus, so we're going to need a minus here, and I don't see anything common to these two terms except 1, so we'll use 1 as our GCF. And now to make the signs come out right, we'll need 3y plus 8x. Now before we do the last step, we have to notice that our two binomials are not the same here, so we do not have a common binomial, and that means the grouping method has failed. So we should try rearranging these two middle terms. That's going to give us an original problem of 2xy minus 3y plus 12 minus 8x. And now let's try the grouping method again. The GCF for the first two terms will be y. That's the only thing those two terms share. And in parentheses we're going to have 2x minus 3. The second group now starts with a plus, so we'll have a plus here. And notice that the GCF of these last two terms is 4. So in parentheses 4 times 3 makes 12, and 4 times negative 2x makes negative 8x. Now this time these two binomials are very, very similar, but they are not exactly alike. This one has positive 2x and negative 3. This one has positive 3 and negative 2x. And we can't go ahead with our third step until these two binomials are exactly alike. So what I want us to do is factor out a negative 1 from this set of parentheses. So we'll leave that first group alone, and now we'll factor out a negative 1 from here, which is going to change this positive 4 to a negative 4. And that's going to change this positive 3 to a negative 3, and this term will change to positive 2x. Now notice that if we were to distribute the negative 4 times negative 3 is positive 12, and negative 4 times positive 2x is negative 8x. So we really haven't changed anything. We've just factored out a negative, so we changed the way it looks. Now notice that these two binomials are identical. They're not written in the same order, but they do contain the same terms. So that means we can factor out a common binomial of 2x minus 3, and in the second set of parentheses we'll have y minus 4. Now if you wanted to check your work on this, you could just use the FOIL method to put this back together, and you would see that we get the same four terms we started with.